This is the Pythagorean theorem. The Pythagorean theorem was proved by a guy named Pythagoras many years ago. It's all based on a right triangle. Again, a right triangle, you have a right angle. Opposite the right angle is called the hypotenuse. That's the longest side. And then you have the two legs, or the two sides of the triangle. Angles are capital letters. That's how you mark a triangle. Notice it is capital C. That's referring to angle C. Capital A is referring to angle A. Capital B is referring to angle B. And then sides are lowercase. So in this problem, if this is angle C, opposite of that is side C, lowercase. Opposite of, here's angle B. Notice it's capital B. Opposite of that is side B. And here's angle A, and opposite of that is side A. Again, lowercase for sides. The longest side is called the hypotenuse. The Pythagorean theorem, Pythagoras noticed that, again, here's a right triangle right here, and if you have a square, this is side length 3, and if you square that, there's 9 squares, and the same thing, side length 4, which is 4 by 4, that's 16 squares, and the hypotenuse is 5, so 5 times 5 would be a 25 square units here. And they noticed that the sum of these two legs squared, and the square of that, is 9 plus 16 is 25. So Pythagoras made a theorem that says the hypotenuse squared equals the leg squared plus the leg squared. In other words, c squared equals a squared plus b squared. This right here is the Pythagorean theorem. And you're going to be using that formula on right triangles. All right, so here's 4 triangles. And notice that the sides, the triangles are rotated somewhat. And I did this on purpose so that you could see the difference of the where the right triangle is in the hypotenuse. So here's angle A. So side A is right here. This is side A. This is angle B. So side B would be right here. Again, notice I'm using lower cases for the sides. This is angle C, the right angle. So opposite of that is the hypotenuse, which is side C. The hypotenuse is always the longest side, is always C. So here's what you do. You write the formula, the Pythagorean theorem, c squared equals a squared plus b squared. The c is always your hypotenuse. So in this problem, I do not know the hypotenuse. So keep it c squared. A squared would be 7 squared, and then b squared would be 4 squared. And then you're just going to solve this. 7 squared is 49, 4 squared is 16. And you're going to get 65 when you add those together. And how do you solve this? Well, now you take the square root of both sides. So c equals the square root of 65. Now, normally, when you take the square root of both sides, it's plus and minus. But remember, we're talking about the length of a triangle, of the side of a triangle. You can't have the negative length. So in this problem, you would actually get c as being the square root of 65. And if I ask you for a decimal, then you would say 8 point something, 8.1, and whatever the decimal is for that. All right, let's try another one. This is c squared equals a squared plus b squared. Always write the formula. It will help you out. So c squared, notice this triangle is rotated on purpose. The c is, again, opposite of that. That's 12. That's the hypotenuse. So in this problem, I actually know the c. The a, opposite the angle A, is side A, so that's a squared. And then in this case, b squared, I don't know my b. Again, just follow the formula. This is 144 equals 64 plus b squared. Minus 64 from both sides. B squared equals 80. Take the square root of both sides. Again, it all depends on the directions. If it asks you to use just give me an answer, decimal answer, then you can use your calculator. But if it doesn't, and always assume that it doesn't say it. So you need to know how to simplify the square root of 80. And again, if you think about the square root of 80, think of 2 things that multiply together, 16 and 5, and the square root of 16 is 4. So 4 square root of 5. And remember, don't put plus or minus because it's not a negative distance. So b over here is 4 square root of 5. Let's try another one. Write the formula c squared equals a squared plus b squared. The c, again, on this problem, I do not know. Opposite the angle c is side of these. A squared would be 13 squared. B squared would be 12 squared. 13 squared is 169. 12 squared is 144. We're going to add those together. $313. And then I'm going to take the square root of both sides. And again, you're just going to leave it as square root of 313. If it can be simplified, then you simplify it. And again, don't include the negative. It's only the positive because you're talking about the length. And keep in mind, the way to check this, the square root of 313 should be the longest side because remember the hypotenuse is the longest. So that's one way to check it. If you got a decimal answer to that, it would actually be bigger than 13. All right, let's try one more. C squared equals A squared plus B squared. The C is the hypotenuse, so 9 squared, I do know. A squared, I do know. And again, in this problem, I don't know the B again. So B squared. So 81 equals 25 plus B squared. Again, I'm minus 25 from both sides. Get 56. Take the square root of both sides. And again, if 56 could be simplified, then simplify it. So let's come over here and take the square root of 56. And I know that 56 can be broken down to 8 times 7, if you wanted to do it that way, or 4 times 14, which I'm going to do that way. And then the square root of 4 is 2, and square root of 14. So 2 square root of 14. That's how you would solve right triangles using the Pythagorean theorem.